So you've got this perfect algorithm, right? The one that works flawlessly in theory. But what happens when you throw it out into the real world, into a production system? That's what we're digging into today, the often brutal, always fascinating journey from the whiteboard to reality. And it always starts here, in this, perfect, clean world. On a whiteboard, everything is pristine. Your inputs are exactly what you expect, the data is clean, it's just pure, beautiful logic. But of course, that's not where the story ends. The real world is, well, it's a lot messier. And the first big slap in the face from reality, latency. All of a sudden, nothing is instant anymore. Data has to crawl across networks, wait in line. Every single click, every calculation, it's got a delay baked in. And that delay, it can totally shatter the assumptions your algorithm was built on. Next up, you meet failure. And here's the thing. It's not like a light switch, just on or off. No. In production, things are always partially broken. A server is kinda slow, a database is dropping some data, the network is flaky. Your algorithm has to walk through this minefield where nothing is ever 100% working. And then, of course, you add the most chaotic ingredient to the mix, us. People. We're the ones clicking a button 1,000 times, putting emojis where they don't belong, and just generally using the system in ways no sane person could have ever predicted. We are the ultimate stress test.
So, you see, this isn't just about moving to a bigger computer. It's a gauntlet. Production isn't just a place. It's this hostile environment that's practically designed to find every single weakness in your beautiful, theoretical algorithm and exploit it.
Okay, let's really break down what this gauntlet looks like. You've got inputs with no limits. You have no idea how much data is about to hit you. You've got thousands of people all trying to do things at the exact same time. Then there are those constant network delays and partial failures we talked about. And on top of everything, you've got a budget. Every single CPU cycle, every bit of memory, it all costs real money.
And this is the absolute key takeaway. You can't just think of production as a bigger test case. It's not. It is a completely different problem. The mindset has to shift entirely. You're not just scaling up, you're solving for a whole new reality.
So, the big question is, how do you survive this? How does an algorithm make it through? Well, you have to play by a whole new set of rules. What it means to be a good algorithm completely changes.
And this comparison just lays it out so clearly. On the whiteboard, it's all about correctness, finding that one single optimal answer. But in the real world, the priorities flip. We need reliability. Does it just work? We need it to be recoverable. What's the plan for when it breaks? Because it will. And we need it to be predictable. Fast on average doesn't cut it when some users are waiting forever. This really gets to the heart of it. I mean, think about it from a business perspective. Would you rather have a website that gives good enough recommendations but is always up and running, or one that gives the perfect recommendation but crashes every time there's a holiday sale? It's a no-brainer. Availability is king.
And it's not just our values that change. How we measure performance gets a total makeover too. In school, you learn all about Big O, this theoretical idea of how an algorithm scales. But in production, we live and die by something called tail latency. That's the P99 number, the experience of your unluckiest 1% of users, because those are the ones who complain on social media. The real bottlenecks aren't abstract computation steps. They're very real things like waiting for the network.
So what does this mean? It means you have to design for failure from the very beginning. Assume everything will break. A great example is when you handle payments. What if someone clicks buy and their internet glitches so they click it again? You can't charge them twice. That's where a concept called idempotency comes in. It's a fancy word that just means an operation can be run over and over, but it only has an effect the first time. It's basically a no double charge guarantee built right in.
Okay, so this brings us to a really interesting, kind of next level idea. It's not just about surviving imperfection. It's about using it. It's about embracing imperfection as a tool to build something even better. And that's the whole world of approximation algorithms. Now, these aren't broken or bad algorithms, not at all. They are super clever solutions that intentionally trade a little bit of precision for a massive gain in speed or scale. It's a strategic, calculated move. And you see this stuff everywhere once you know to look for it. Take a Bloom filter. It can tell you in a split second if a username is probably taken. There's a tiny chance it's wrong, but it saves a super slow database lookup 99.9% of the time. Or load shedding. When a site gets slammed with traffic, it basically becomes a bouncer at a nightclub. Sorry, we're full, and starts turning people away so that the people already inside can still have a good time. It's all about making smart sacrifices. And here it is, the golden rule, again. Precision is a knob you can turn. Availability? That's often a switch.
It's on or it's off. For almost everything we do online, from your social feed to a search result, a good enough answer right now is way better than a perfect answer that never arrives. All right, so let's say you've done all this. You've built your smart, resilient, trade-off-aware algorithm. It's out there running in the wild. But how do you know it's actually healthy? How do you peek inside that black box?
The answer is you need a really strong feedback loop. You have to ask 3 questions. 1. Is it observable? Can I even see what it's doing? 2. Is it measurable? Am I tracking the metrics that actually matter? And 3. Is it tunable? Can I tweak its behavior in real time? Without this stuff, your algorithm can just silently rot, and you won't have a clue until your users start screaming.
But even after all of that, all the brilliant technical work, there's one final piece of the puzzle. The most complex and unpredictable part. See, algorithms don't just run on computers. They're run by humans.
And this is the ultimate, humbling truth of engineering. If there's a way for a human to mess it up, eventually someone will. A confusing dashboard, a button with a scary name, these things can cause just as much damage as a hardware failure. The system has to be designed to be resilient against us.
So let's pull this all together. What have we learned? The biggest lesson from this whole journey, from the whiteboard to the real world, is that the algorithm itself is never the whole story. It's just one piece.
They don't run in a vacuum. They run inside of complex systems. They're just one cog in a giant machine, and their success depends entirely on everything else around them.
And these systems, they aren't built in a lab. They are forged in the messy, chaotic reality of the real world. They're shaped by budgets, by constant failures, and of course, by people.
So in the end, what is this all about? It's about recognizing that production engineering is an art. It's the art of taking a pure, beautiful idea and giving it the armor it needs to survive reality. It's about making sure our best algorithms can actually handle the real world.